In this lesson, we will learn how to perform the hypothesis test for the difference of population proportions. In a random sample of 260 potential voters registered in the state of Texas, 107 indicated that they planned to vote in the next general election. In an independently chosen random sample of 259 potential voters registered in South Carolina, 78 indicated that they planned to vote in the next general election. Can we conclude, at the 0.05 level of significance, that the proportion P1 of all potential voters in Texas who plan to vote is greater than the proportion P2 of all potential voters in South Carolina who plan to vote? Perform a one-tailed test, then fill in the table below. Carry your intermediate computations to at least 3 decimal places and round your answers as specified in the table. If necessary, consult a list of formulas. From the information I have, I can conclude that I'm given 2 sample proportions, p hat sub 1 and p hat sub 2. The first one is 107 out of 260. The second one is 78 out of 259. The question is, can we conclude that among all potential voters in Texas who plan to vote, is that proportion greater than the proportion of potential voters in South Carolina? So I'm asking, is P1 greater than P2, which equivalently can be expressed as, is the difference between P1 and P2 greater than 0? So I'm setting up my hypothesis statements. H sub 0 is P1 minus P2 is less than or equal to 0, and H sub 1 is P1 minus P2 is greater than 0. That is what I'm trying to find evidence for. We'll see if it works out. Alpha is 0.05, and I'm going to need a critical value because this particular question on ALEKS is asking us to use the critical value approach to solving this problem. So I need to know what is the z-value that separates 5% in the right tail from 95% on the left side of that critical value. Why 5%? Because of alpha is 500th, and why in the right tail? Because that is a right tail test according to this alternative hypothesis inequality symbol. So I use the inverse norm to find z sub 0.05. Which is 1.645. So this location on the z-axis is 1.645. Now it's time to find the test statistic. I'm utilizing option 6 on the list of tests called 2 proportion z test. And it gives me z-value, which is test statistic, of 2.625 and p-value of 0.004. Please notice, because this test statistic 2.625 happens to be on the right side or in the critical region with respect to this critical value, I can conclude that we must reject null hypothesis. So I conclude there is enough evidence at alpha equals 0.05 significance level that the proportion of voters in Texas who plan to vote is higher than in South Carolina. The table above shows how I would enter my answers in ALEKS. I need to state my null hypothesis, then alternative hypothesis, then I need to indicate what type of test statistic I will be working with, and it is z. Then I need to state specifically what my z value is for test statistic, which is 2.625. Then I need to identify the critical value, 1.645, and choose whether I need to answer yes or no. In this case, the question was, can we conclude that the proportion of voters in Texas who plan to vote is greater than the proportion of voters in South Carolina who plan to vote? And we concluded it is true, and therefore I say yes.